Okay, so let f of x equals x squared plus 1. If you want to sketch this in your graphing calculator or whatever, it helps with a precise graph. Let R be the region under the graph from 1 to 3. This is your A and your B. Approximate the area of R using, for part A, we're going to do inscribed, which is going to be under the curve. So this one's going to be a little less than our actual. They tell us our delta x is 1/2. And then the second time we're going to go back and use our calculations using circumscribed, which is above the graph of rectangular polygons. So let's see this example. Okay, use your calculator or whatever methods. This is x squared plus 1. I just plugged in a little xy table right here to get a rough sketch of this graph. Okay, whatever you need to do. I'm going to move that out the way. And now we want to write down our formula, which is going to be area of an inscribed polygon is going to be the sum when k equals 1 to n of f of uk delta x. Now we're going to fill this in. So k is equal to 1. The function f evaluated, our function is x squared plus 1. That was given to us. So that's going to be this information right here was given to us. Not only that, so was delta x. What did they tell us delta x is going to be? 1/2. Okay, that was given in the problem. Alright, now if our delta x is 1/2, so from here to here is 1, so my first rectangle is going to be at the half points, right? So 1/2, 1/2, 1/2, and 1/2, and I do that all the way till I get from 1 to 3, right? So A is 1 to 3. Okay, I had to erase that. I didn't go out to 3. 3 is at 10, which is not going to necessarily be included on my graph, but extend yours to make it happen. So also, if I look back, it tells me from 1 to 3. So I'm only working with the region from 1 to 3, and I want my rectangles to be delta x is 1/2. Delta x is the width of the rectangle, so it's 1/2. So from 1 to 1/2 is going to be a rectangle. So if I start up at the 1, I go over, I'm going to stop at 1/2. Okay, my next rectangle needs to be a width of 1/2, so I go up till I hit the function and I come back down. That's 1/2. Okay, so I go up till I hit half interval. I'm trying to do a rough sketch. And then this one, which of course my 10's off the page, but it's a rough estimate. Okay, so that is where right here, the width right here is delta x is equal to 1/2. Okay, so now what we want to do is find the area of each of these rectangles, right? How many rectangles do we end up having to have? 4. So what is what's your n value going to be? We're going to do that how many times? 4. We're going to do the sum of 4, so good. This becomes a 4. Also, there's a formula off to the side. N is equal to your b minus a divided by delta x. So if I use the formula, which visually we saw that we have 4 rectangles over here. Let me finish sketching these out. But I also have a formula. The number of rectangles you're in right here can be found by this formula. B minus a, which in this case would be 3 minus 1 is 2 divided by 1/2. So this would be b minus a divided by 1/2. That's just going to be n is equal to 2 divided by 1/2, which is just 4. That's the same thing that we got. Okay, so I'm going to move this out the way. I'll leave that formula up there. Now what we're going to do is we're going to use properties. We're going to pull the 1/2 out front, and we're just going to have our summation. We're going to calculate our summation next. So we just have x squared plus 1. We're going to actually just evaluate that sum and then multiply it times 1/2. So I'm going to bring my 1/2 out and we're going to do x squared starting at 1. So that's 1 squared plus 1. That's the first term. And then we have what's the next term? Well, the next term, if this one was 1, what's this one? 1/2 or 1.5, right? So let's do 3/2 squared plus 1. What's our next spot right here? 2. 2 squared plus 1. And then what's this next one? The beginning of the next one. Yes, so which is 5/2 squared, or if you put 2.5, that's the same thing. Plus 1. Okay, and now we're just going to calculate those. So that's going to be 1/2. So 1 squared plus 1, and that gives us 2. 3 squared is going to be 9/4 plus 1, which is 13/4. 2 squared is 4 plus 1 is 5. 25/4 plus 1 is 29/4. Okay, so that would give us 1/2. The whole inside, when you add them all up, should give you 35/2 when you get a common denominator and simplify. And then when we multiply that out, we'll come over here. We should simplify to be 35/4. So I'll give you a few minutes to pause this so you can do your fractions, calculate your fractions, and then check your answer, which this is approximately 8.75 units squared. Okay, using the same information before, I'm trying to just sketch this out, but I'll show you how we draw the rectangles for circumscribed. So remember our delta x was 1/2, and we're only going from the regions from 1 to 3. So if I go over 1/2, that puts me here. Now I want to go up till I hit my function, and this time I'm going to extend that out to the left. And so this is my right hand endpoint, so to say. Now I'm going to go over 1/2. A delta x is 1/2. If I go up till I hit the function and then come back over, that's going to be where it hits the function. I'll do 1/2 again. And so this is our overestimation. So it's with right hand endpoints. Where if you notice the other one, okay, let me sketch back. We evaluated our points right here, left hand endpoint. So it's the left point of the triangle that touched our function, and that's why we used 1, 3/2, 2, and 5/2. So the only difference in part A and part B is now this is an overestimation, and we're going to start with the right hand endpoints, which are going to be 3/2, then 2, then 5/2, and then 3. So that's the only difference between the two, and I'll write that formula out and get started on that. Okay, so basically I just sketched that. I'm going to do the area of this rectangle, then this one, and this one. I'm going to add them all up. That's what this says. We have 4 rectangles total, so that's going to be our 4. The function of v sub k, I just, instead of leaving it u sub k because it was the underestimation, it was our inscribed, I just used a different notation, v sub k, so that we can remember it's above the graph. And delta x was given to us, so if I just substitute in from here, I get the sum k equals 1 to 4 because it's 4 rectangles. Our function is still the same. And delta x is 1/2, which remember we pulled it out front before, so that's the delta x, which is 1/2. I just went ahead and pulled it out front. Now we want to evaluate this, so bring my 1/2. The sum of those rectangles. So my very first position, remember we're starting with, it's the right hand endpoint of my rectangle that touches the function there. So I'm going to start with 3, which is 1.5. So that's 1.5 right there. 1.5 squared plus 1. Okay. My next one is going to be this point, which is at the value 2 when x is 2, so 2 squared plus 1. My next term is going to be at this point, which is 5 halves, so that's 5 halves squared plus 1. And then my last term, I'm trying to separate these a little bit so you can see them, is going to be the right hand endpoint is at 3, so that's going to be 3 squared plus 1. We'll just do the calculations on those. 9 fourths plus 1 is going to give you 13 fourths right there. 2 squared plus 1 is 5. This term, which is all together, is 5 squared, so that's 25 fourths plus 1, which would be 29 fourths. And then 3 squared is 9 plus 1 is 10. Calculate those up. I finished with 51 fourths, which is approximately 12.75 units square. So you can see this one's a little bit of an overestimation, and the previous one was a little bit of an underestimation. Now, what we're going to consider now is the first time we went completely under the graph using a left-hand endpoint of this particular rectangle. We have a right-hand endpoint, which gave us a little bit of an overestimation. So what do you think would happen if we did a midpoint? What if we chose in the middle? What kind of estimation would that give us? So the next one we're going to do a midpoint just to extend this a little bit further.